When we approach a math problem that we don't know how to solve immediately, what do? What kind of questions should we ask? What kinds of things should we try to give us the best chance at solving it in a reasonable amount of time? There are some general strategies that we can apply to a variety of different types of questions. Let's look at this puzzle here. Which is larger, 2 to the 3,000 or 3 to the 2,000? Now, when we initially look at a question like this, it's often helpful to think about the easiest way to do it. So initially, we might just say, how much is it? And we'll assume that we don't have a computer which can calculate out the actual value. But for this one, if we did multiply it out by hand, it would take way too long to do. So we want to think about another way to do it. Maybe we could just use some logic here. If we were to start multiplying these out, we would see that after the first 2,000 multiplications, the 3 to the 2,000 would be much larger. But then, while the first one would stop, the 2 to the 3,000 would be going on for another 1,000 multiplications by 2. Would this be enough to catch up? It's hard to tell, and it may not be easy to see a way to figure that out, although we could think about it some more and maybe come up with something later on. Now that we've thought about the question a little bit, what we might want to think about next is, what's the difficulty here? What's holding us back? The problem is that both the base and the exponents are different. That's really the issue. For example, if they both had the same base, then we could just see which had the bigger exponent and be done with it. Or, if they had the same exponent, then whichever one had the larger base would be biggest. So now that we see what the issue is, let's take away the issue. Now, how can we do that? Well, here, we can try to rewrite these so that they either have the same base or the same exponent. If we can do that, then we have an easier problem to solve, one that we already know how to do. Can we make the bases the same? That seems tough initially because they're both prime numbers. We can't break these up at all. We could do something like write 3 as 2 times 3 halves, but then we still have something with a different base and exponent. So we might not see how that gets us anywhere right away, but we can revisit it later on and put more thought into it if we need to. What about rewriting the exponents? Now, this is something that's much more familiar to us since we have laws of exponents. And in this case, one particular law of exponents can be super helpful. In this example here, we have 5 cubed to the 4th power, and we know we can rewrite this as 5 to the 12th, because what we really have here is 5 times 5 times 5, and we have that 4 times, all multiplied together. In other words, we have 4 groups of 3 5s multiplied together for a total of 12 5s. And this is how we usually use this law, to make things more concise. But we could also use it in reverse. If we had 5 to the 12th, we can write that as 5 cubed to the 4th, or 5 to the 4th cubed, or 5 squared to the 6th, or whatever we want, as long as the exponents multiply to 12. That's our choice. Now let's look back at our original question. We can write these exponents as any factors of 2,000 and 3,000 that we like, but remember, it would be easiest if they were the same. Since they both have the word 1,000 in them, let's break 3,000 into 3 times 1,000, and 2,000 into 2 times 1,000. So we have that 2 to the 3,000 is the same as 2 cubed all to the 1,000, and 3 to the 2,000 is the same as 3 squared all to the 1,000. We can easily simplify now what's in these parentheses since we have much smaller exponents here, giving us that 2 cubed is 8 and 3 squared is 9, both to the 1,000 power. Now we can clearly see that 9 to the 1,000 is larger than 8 to the 1,000. And so our 3 to the 2,000 is the larger of the two numbers. Oftentimes, when we encounter something we don't know how to do, it really helps to follow these steps here. First, experiment. Play around with it a little bit just to see what's going on. Then, through your experimentation, analyze what those difficulties really are. And then finally, think about ways to eliminate those difficulties and simplify the problem. How to do this last step is often the trickiest part, but through our experimentation and analysis, we usually will get some hints as to the direction that we might go. And if something doesn't work, don't completely disregard it. A lot of times we can learn some information from what didn't work, and that can help us to eventually find a good path to solving the problem.